In this example problem, we're going to take on the role of a security analyst for a telecommunications firm called WebTalk. We are, in general, pretty optimistic about our firm's future, but we do have a concern. We are concerned that the credit flow in the economy may change. What is that? It's the amount of money that banks will allow people to borrow from them on credit. So if banks make it affordable and easy for people to borrow money, they have more money to work with. Maybe they'll buy some more stocks with available cash they have, and it should drive stock prices up. Well, if the inverse of that happens and banks make it more difficult for people to acquire money, decrease the credit flow, if you will, puts less available money to be spent in the stock market, which with the law of supply and demand can drive stock prices down. This analyst is making the following assumptions right here. He believes that the probability is 20% that credit flow will improve significantly, a big chunk. There's a 50% chance that it will improve only marginally, and a 30% chance that there will be no improvements to credit flow at all. He's also making an estimate that the probability the stock price of WebTalk will go up is 90% if there's significant improvement. Makes sense. So more money into the economy should increase the number of transactions within the stock market, the overall demand driving price up. A 40% chance that the stock price will go up if there's only marginal improvement to the economy's credit flow, and then a 10% chance it will increase if there's no improvement to the credit flow. We're going to try to figure out right here, based upon all these estimates above, firstly, what is the probability that the stock price of WebTalk is going to increase overall? And what is the probability that credit flow in the economy has improved significantly given that the stock price increased? So what we're going to do is we're going to start with our prior probabilities of what we thought things were going to be in terms of credit flow in the economy. And we said that the probability of a significant improvement in this case was going to be 20%. The analyst is making an estimate here that the probability of only marginal improvement, the P of M, if you will, was 50%. Should have a decimal in there. There we go. And the probability there is no improvement at all, N, was the remaining 30%. And I say remaining because if you find the sum of these numbers up above, it's got to add up to 1. And those are the three outcomes we have. Well, I guess there's a 0 chance that it's going to be a decline in the credit flow in the economy. So these are the three outcomes we're looking for, and they're exhaustive. All of them have to add up to the full 100%. Well, what is our conditional probabilities right here? I given S, I given M, I given N. That's the probability of improvement should each one of these three respective changes to the overall credit flow of the economy incur. And that's the second set of numbers that we have right here. We say conditionally that if there is a significant improvement to credit flow in the economy, there's a 90% chance that the stock price increases. If there is a marginal improvement to credit flow, well, we're only estimating that there's a 40% chance. And if there is no improvement at all, we're estimating there's only a 10% chance that our stock price increases, goes up. So what is the joint probability? Well, it's just these two numbers multiplied together. There's a 20% chance of significant improvement. And out of that 20% of the time, only 90% of the time within that 20%, will that cause the stock price to increase. So overall, starting from day one right here, the chance that we have that we're going to have a significant improvement to credit flow and our stock price is going to increase is 18%. What about an increase if there is marginal improvement? Well, we're saying the chance that there's only marginal improvement to the credit flow in the economy is 50%, and of that, only 40% of the time will it cause our stock price to increase. So if we multiply those two numbers together, we come up with 20. There's a 20% probability that there will be marginal improvement to our economy's credit flow, but our stock price will still increase. And what is the overall probability that there will be an increase of our stock price and there's going to be no improvement to the credit flow in the economy? So borrowing is going to stay the same that it is, but for one reason or another, besides the extra available money, we're still going to have an increase to our stock price. Same concept. 30% of the time, we're estimating there'll be no improvement to the credit flow. And of that, there's only a 10% chance out of that 30% chance that there'll be an increase to our stock price, which means only 3% of the time if there's no improvement to the economy's credit flow, can we expect our stock price to increase? So overall, what's the probability that we have of an increase during the upcoming period? Well, these are our only three conditions. And again, we're looking at an economy here that we're not expecting a decrease in credit flow, so it's either going to improve significantly, marginally, or not at all. And these are the probabilities in each of those three instances here that there will be an increase. So the total probability of an increase is just going to be equal to the sum of all of the numbers up above. Our estimate right now, based upon our estimate of how the economy is going to change in terms of credit flow and how we expect our stock price to change based upon that credit flow, says that WebTalk has a 41% chance of having their stock price increase. So that's the answer to A. What about B? The probability that the credit flow in the economy has improved significantly given that our stock price has gone up. And that's the same thing that we had before. When you're trying to find the probability of one thing given another item, you take the probability of both of them happening and divide by the probability of what is given. So in our case right here, our posterior probability, our probability that credit flow in the economy will improve significantly, knowing that the price of WebTalk has gone up, is equal to the and of both of these divided by the probability of what was given, our condition, which was 41%. So 0.18 divided by 0.41 comes up to 0.439. If there is an increase in the price of our stock during the upcoming period, well, then there's got to be a 43% chance that the reason that happened is because there was a significant increase to the credit flow in our economy. Let's go through and do one more of these. Very similar question, this time in a little bit different realm. We are the Los Angeles Lakers. If anybody out there is a basketball fan, you'll be familiar with this team and this player. We have a crucial game coming up, and it fully depends on the health of one of our key players, whose name just happens to be LeBron James, most likely. According to doctors' reports, there's a 40% chance that he'll be fit to play, a 30% chance he'll only be somewhat fit to play, and a 30% chance that he'll not be able to play at all. And that's our F, our S, and our N. The coach has estimated that if our key player here has an 80% chance of, if he's fully fit to play, we have an 80% chance of winning. If he plays hurt, if he's somewhat fit to play, our chance of winning declines to just 60%. And if he's unable to play at all, our chance of winning this crucial game is only going to be 40%. We're asked to find what the probability is overall that we're going to win this game, regardless of if this player plays or not. And what is the probability that the key player is going to be fully healthy if we win the game. So just like we did before. Our prior probabilities are listed up above. There is a 40% chance that our key player, I was in the wrong cell. There's a 40% chance that our key player is going to be fully fit to play. There's a 30% chance that he's somewhat fit to play, and a 30% chance that he's not fit to play at all. Just stealing these numbers from up here and bringing them down there. And just to be thorough, we make sure that that is indeed exhaustive, that it adds up to 1, and it does. Our conditional probabilities that are given in the problem is that if this player is fully fit to play, our chance of winning is 80%. If this player is somewhat fit to play, our chance of winning declines down to 60%. And if this player does not play at all during this upcoming game, our chance of winning decreases greatly, all the way down to 40%. Well, now we need the joint probabilities of both of these instances happening. What we can do is we can just add them, or multiply them by one another, So if there's a 40% chance that our player is going to be fully fit, and out of that 40% chance, 80% of the time we win, well, that means overall there's a 32% combined joint probability that our player is going to be fully fit and we're going to win the game. What if our player is somewhat fit to play and we still win the game? What's the chance of that happening? Well, that would be the 30% of the time he's going to play somewhat fit times our 60% chance of winning in that event. Comes out to 0.18, and we'll do the same thing down here. If the player does not play, which is going to be 30% of the time, our chance only comes down to 40% of winning, which means overall the probability that we win this game, even if this person does not play, is 12%. So what's our probability of winning? just like before, we add up the sum of all these numbers. And that's going to come up to be 62. We have a 62% chance of winning this game. So while it does hinge on this player's performance, our probability obviously goes up the healthier this certain key player is. Overall, we are saying right here that regardless if this person is going to play at the beginning of the game, not knowing what the health's going to be, could be playing, could not be playing, could be playing in full ready to go condition, could be playing banged up and have to play, hurt. Overall, out of all these instances, they give us a 62% combined chance of winning this game. What is our posterior probability? The probability that the key player was fully healthy and that we won the game. Well, same thing before. Take the probability of both events happening, which right here would be 32%, and divide it by the probability of what's given. So in this instance, 32% is the probability that both events happen, divided by what is given, our 62% chance of winning the game, we come up with 0.5161. So if we ended up winning this game more than half the time, it's going to be because our key player was healthy enough to carry us to victory.